So I'm going to be talking about ionic compounds and what an ionic compound is. Basically, is when one element gives one or more electrons to another element. Um, and it's really important that this happens because every element has a valence shell, which means the shell or cloud of electrons that is the farthest away from the nucleus, or the neutrons and the protons that are conglomerated in the center. Um, they want to fill that because as that valence shell fills with 8 electrons, it becomes more stable, and that's the equilibrium that nature wants. There are some ways that you can notate this, that you can put this into literature almost, and that is to assign each shell and each electron a, a symbol, so to say. So like, if I say 1s1, that is the first row, is the first one. The S is the first group, and then the 1, which would be superscripts in your writing, shows that there's one valence electron. If I said 1s2, it's the same thing, but because we have a 2, we have a full valence shell, because the first 2 elements, hydrogen and helium, are actually, they follow duet rules as opposed to octet rules, as every other element does. So in general, you want to fill them with 8. So when 2 elements come together so that they can fill their valence shells together, it's usually between a cation, which is a positively charged element, and an anion, which those come as results of the bonding. So let's take an example. Let's say lithium, which has 1 valence electron in its outer shell, and fluorine, which has 7. If they came together and lithium had its 1 electron go over to fluorine, then the lithium's valence shell, the original one, disappears because there's no electrons there anymore, and you're just making up a fake shell of electrons that isn't there. And so its valence shell becomes full because the next one down is already full of electrons. And the fluorine gains that electron and adds it to its 7, and it becomes 8, and you have a full valence shell. And both of the elements are now at a peaceful state. They don't need to go crazy and explode or kill people. So as elements do this with each other, they form compounds which have kind of a weird nomenclature to them. As 2 elements come together, their name turns into something that you might not expect from those 2 elements. So let's say lithium and fluorine. It doesn't become lithium fluorine. It might become lithium fluoride. If it was lithium and 1 fluorine, you change the suffix, well, not the suffix, but the end of the second word. And it's different for every element. And it's different for metals and nonmetals. They have different rules. There are exceptions in what makes a full valence shell, because there are some metals that don't follow the octet rule. But let's take, for example, copper and lead. Lead in Latin is ferro, and that's what we use to call it in chemistry. It's something is ferrous, and copper is cuprous. So depending on whether or not you have a positively charged copper ion or a copper ion that has been doubly negatively charged with two negatives, which means that there's two extra electrons, it becomes cupric. And then you add one more and it becomes cuprous. It's the same thing for lead. You can have ferric or ferrous. And depending on the way that the bond was formed, you can come up with either one. When nonmetals bond, it's usually in greater mass if there's not an alkaline earth element involved, because they all have very full valence shells. They're not completely full, but if you took a bunch of group 7 elements and you only had group 7 elements to work with, each one has 7, so let's say you put 2 together and then you have 14, and then one of them needs 6 more. So you have to keep adding and adding, and with a group 7 element you would need 8 to fill all of their valence shells. And that's a lot different than having a metal form an ion with a non-metal. That's it.